So we're going to solve quadratic equations by completing the square. But let me be abundantly honest with you. No human in their right mind would choose to solve a quadratic equation by completing the square if there was any other method available. So now you're thinking, why in the heck then would she teach it to me? Well, the truth is, completing the square isn't something that we want to use very often for solving, but it's definitely important in graphing. It creates a form in the quadratic equation that makes graphing super easy. And once you've done half the work to get there, you might as well go ahead and solve by completing the square. So let's get down to business. So the first thing is we want to take a little mini lesson and talk about perfect square binomials. Let's talk for a second though. What's a perfect square? Well, we know that the number 4 is a perfect square because 4 is the result of 2 squared. 2 squared gives you 4, so 4 is called a perfect square. 3 squared is 9, that's a perfect square. And 4 squared is 16. 16 is a perfect square. So in the integers, whenever you square an integer, you end up with a perfect square. Polynomials have their own sort of perfect square though. In polynomial world, if you square a linear binomial, x minus 3 squared, then you get a perfect square trinomial. So the linear binomial x minus 3 can be squared by writing x minus 3 times x minus 3. In the same way that 2 squared is written as 2 times 2, and 3 squared is written as 3 times 3, and so on. A perfect square, or a square of a binomial, means you just take the number, the binomial, and square it. Now, if I multiply it, which means square this, I would get x squared minus 6x plus 9. So this is a perfect square trinomial. If I want to go all the way, I could say it's a perfect square quadratic trinomial. So I think I'm going to do an example and I'll write the steps out as I go. We want to complete the square on x squared plus 6x minus 7 equals 0. At a glance, I can tell that this would be a great choice for pi and sigma method of factoring, but we're not going to pi and sigma. We're going to use complete the square. And remember, completing the square is just a method, M-A-T-H-O-D, which means that it's a set of steps that you're going to follow. Even if they don't make sense to you, that's okay, as long as you just follow the process. It'll do the work for you. It's not something that you necessarily have to understand. It's just a process you need to learn. So the first step in completing the square is we're going to group the x terms and then we're going to factor out, or ME, the leading coefficient. So we're going to ME the LC. I know that makes no sense to you, but it's a method. It doesn't have to. Let me explain what you're going to do. First, we're going to group the terms containing x variables. Quadratic term has an x in it, and the linear term has an x in it. The constant term does not have an x in it. So I'm going to group together the terms with x variables in them. And then I want to ME the leading coefficient, meaning monomial extract. That means I'm going to divide out whatever the leading coefficient is. In this case, the leading coefficient is 1. And so if I divide it out, I get something redundant. 1 times x squared, because x squared divided by 1 is x squared, plus 6x divided by 1 is still 6x. So I can write it down as having been factored out, or I can skip that step if there's not a leading coefficient other than 1. If the leading coefficient is 1. In this case, that's okay. I just factored it out. Could have skipped that step, obviously. Second step is to solve for your grouped term, right? So solve for the parens. So we're going to solve for what's inside the parentheses. That means I'm going to keep all of this on one side of the equation. I'm going to move everything to the other side. The only thing I really have to move to the other side is the -7. I'm going to add that to both sides. So I get x squared plus 6x equals +7 divided by 1 equals 7. So now the next step is to make room for the new term. And what that means is we're going to actually create a new term that makes this side of the equation, the left-hand side of the equation, we're going to make this a perfect square trinomial. If we have a perfect square trinomial, we should be able to backward fit it to look like the square of a binomial. And this is what we want right here. So we're going to make a perfect square trinomial so we can go backward to find out what I would have to square to get that. So I'm going to make room for the new term, and it looks like this. X squared plus 6x plus my new term. I don't really need the parentheses, but I'm going to go ahead and keep them for now. Equals 7. Well, if I add something to this side of the equation, I have to also add it to this side of the equation, right? Because all I'm doing is balancing an equation. If I have an equal sign and the thing on the left-hand side is the same exact value as the thing on the right-hand side, then if I add something to the left-hand side, in order to keep the equation equal, I have to add the same thing to the right-hand side. Simple algebra right there. Okay, now the next step is we're going to make the new term and put it into the equation. And make the new term as a formula. It's b over 2, the whole thing squared. So in this case, what is b? Well, if this would be, so notice when you write a quadratic trinomial, well, I didn't write one over here, so let's see. I have ax squared plus bx plus c equals 0. Remember, that's the standard form of a quadratic trinomial. So b is whatever number is the coefficient of the linear term. So in this case, b is 6. So my new term is 6 over 2 squared. And then this is very important that you do this. Simplify inside, 3 squared, and then simplify outside. 3 squared equals 9. So 6 divided by 2 is 3. 3 squared is 9. We're going to put this one here. And 3 squared is the same thing as 9. We just want it written in this form here. So 3 squared. Okay, so I put 9 on the left-hand side. I put 9 on the right-hand side. I just wrote them differently is all. Now the next step, get ready. ATAMO. That stands for, and then a miracle occurred. You're going to think a miracle happened. I swear. It's going to look like I did magic. Bigger magic even than magic numbers magic. It's miracle magic. But it's not really magic. I'll show you in a minute that it's really not. I'm going to come back up here and I'm going to take just the x. Let me do that a different way. Let me use color. I'm going to take just the x and just the 3. That's all I want. And I'm going to write x plus 3 squared. Do you see what happened? I created a perfect square trinomial, and then I just popped it into whatever binomial I needed that to be. And the reason I know x plus 3 is I created the 3 special to make a perfect square. I just did what I needed to do, and it was all okay because I did it to both sides, so we're good to go. So let me finish up here. X plus 3 squared equals 7 plus 9 is 16. Okay, I know you're kind of thinking, I don't know about that x plus 3 atomo step. I don't really know about that step. But let's look at it, because all I did was say that this, the left-hand side of this equation, is equal to the right hand, or to the perfect square. I'm saying that this trinomial is equal to this trinomial. Well, let's look. This is the same as x squared plus 6x plus 9, right? 3 squared. This, I'm going to take it over here, x plus 3 squared. Well, what is that? That's x plus 3 times x plus 3. Rainbow, x squared plus 3x plus 3x plus 9, which equals x squared plus 6x plus 9. Isn't that the exact same thing I have here? I have x squared plus 6x plus 3 squared, which is the same thing as 9. So it's not really magic. What I did was I found the number that I needed to have in the constant place of my polynomial, of my trinomial, in order to create a perfect square. And then I just offset the other side of the equation to balance what I changed on the left-hand side. So no magic really occurred again, but it certainly feels like a miracle when you do that. All right, let's move on. So at this stage of the game, I can do one thing for graphing, and then I can do another thing for solving. And since we're solving at this stage of the game, let's go ahead and solve. I have a square of something, so I'm going to use the square root property. I'm going to take the square root of both sides, and that equals x plus 3, because the square root of something squared is just whatever that something is, equals plus or minus square root property. The square root of 16 is 4. So I get a positive 4 and a negative 4. And then x equals plus or minus 4 minus 3. I'm going to subtract 3 from both sides. Now I can separate it into my two answers. There's the version where x equals positive 4 minus 3, and the version where x equals negative 4 minus 3. So I have 4 take away 3 is 1, x equals 1, and x equals negative 7. Those are the two solutions that go to this original equation that I set down. So what do you think about that? Crazy, huh? All right, let's do another example. I might end up doing 2 examples. We'll see how time goes. They're faster than they seem when you first get started with them. I'm going to complete the square on 3x squared plus 12x minus 18 equals 0. So remember, the first step says to group the x terms and ME the leading coefficient. So the leading coefficient is 3. So I'm going to divide both sides, both terms by 3. So I'm only going to ME from the group. And that means that I get a 3 out front. 3 divided by 3x squared divided by 3 is just x squared. 12x divided by 3 is plus 4. Minus 18 equals 0. Give you a second to let that settle in. So I'm going to choose my leading coefficient, and I'm going to pull my leading coefficient out of both of these terms. When I did that, I'm not going to take the x with it. I'm only going to take the leading coefficient. When I do that, it's just simple division. 3x squared divided by 3. The 3's cancel. I'm left with an x squared. 12x divided by 3. 12 divided by 3 equals 4, and I still have an x. Oops, I wrote it wrong. Oh, I'm glad I checked that and did it again and spoke it out again. I'd have found it in a second because I need that x. So that's 4x. There we go. So I still have my terms, my x's, my quadratic and my linear term, but I've taken that 3 out. Next step, solve for my parentheses. So that's going to be 3x squared plus 4x equals, add 18 to both sides, and then divide both sides by 3, so I get x squared plus 4x equals 18 divided by 3 is 6. Okay, we're making progress. Next thing I want to do is make room for my new term. X squared plus 4x plus my new term equals 6 plus my new term. Now I'm going to make my new term, b over 2 squared, which equals 4, because that's my b position. 4 over 2 squared, simplify inside. 2 squared, simplify outside, which means just take the square, is 4. 4 goes in this side. The 2 squared goes on this side. Atomo, this is the big step, right? You're going to take the x and the 2 and make a binomial for your perfect square. So you have x plus 2, and that's going to be squared. I know that seems weird, but it's totally legal. I already showed you once. If I square this number, it's going to give me this one back. So all I've done is rewrite it. I made a perfect square, and then I turned it into a perfect square. And then on the other side, 6 plus 4 equals 10. Now I can take the square root of both sides. So the square root of this side squared just makes the square disappear, and the square root of that side is the square root of 10. So I have x plus 2 equals, remember, square root property, plus or minus the square root of 10. And that doesn't simplify. I wish it did, but it doesn't. Then all I have to do is subtract 2 from both sides, and I get x equals plus or minus the square root of 10 minus 2. And I can write this, separate this, but I can't actually make it any prettier because the square root of 10 is just the square root of 10. So x equals the square root of 10 minus 2, and x equals minus the square root of 10, or negative the square root of 10, or the opposite of the square root of 10, minus 2. Now, this in my world is the complete answer. I don't need any more. I like it looking just like that. But suppose you need to know kind of what it really is. You can put this into your calculator and take the square root of 10 and then subtract 2. And what you get is 1.16. So I don't really like decimals all that much, but if you need the decimal, it's easy enough to do. And then I can put the other one, negative the square root of 10, take away 2, and that equals negative 5.16. Done. Let's do one more. I think I can do it really fast because we have the process down. Let's take 3x squared minus 24x plus 27 equals 0. Group the x terms, factor out the leading coefficient, which is a 3. If I divide 3x squared by 3, I get x squared. If I divide negative 24x, negative 24 divides by 3 to give you negative 8, and I still have the x, plus 27 equals 0. I'm going to subtract 27 from both sides, and then I'm going to divide both sides by 3. So I get x squared minus 8x equals negative 27 divided by 3 is negative 9. Make room for the new term. Plus the new term equals negative 9 plus the new term. Make my new term. Now notice negative 8. Negative 8 over 2 squared equals, simplify inside the parentheses first, negative 4 squared. Negative 4 squared is a positive 16. 16 goes on this side. Negative 4 squared goes on this side. Atomo, I'm going to take the x and the negative 4 and make my binomial. X minus 4, it has to be squared, equals negative 9 plus 16 is positive 7. Square both, or excuse me, take the square root of both sides, which means x minus 4, whoops, that's not what I want. Let's keep my colors in order. X minus 4 equals plus or minus, for the square root property, the square root of 7. Again, a number that doesn't get any prettier than that unless I put it into a calculator and make it a decimal. Add 4 to both sides. X equals plus or minus the square root of 7 plus 4. And if I put this into a calculator, I get x equals, and this is going to be a set. If I choose plus the square root of 7 plus 4, I get 6.65. And if I choose minus the square root of 7 plus 4, I get 1.35. Now remember, these aren't the answers I want. Unless I ask for a decimal answer, I like this answer. This is the one I want to see. Same thing over here. Well, you could give me this one on this one. So I like to see the answer in exact form, unless for some reason you're asked to or you need to put it into a decimal. So that is it. Completing the square brings us to the end of the magical magicness and the miracleness and all of the methods that don't necessarily make sense but get the job done for you.